All right, good evening, fifth graders. Tonight we're going to do a review for Unit 8. It's going to be a little longer video, but of course, press pause, watch, write down some notes, and if you have some questions on certain problems that are going to be on your Unit 8 test, please be sure to ask me during the review tomorrow. Let's get going here. We have 3/10 here. What is that as a decimal? That's pretty easy. It's 0.3, right? It's already written as 3/10. How do we write this as a percent? If I just add a 0 here to be 0.30, my percent would be 30%. Now we have 6/50ths. We have to change this into 10, 100, or 1,000. Let's change it into 100. Times 2 gives me 12 hundredths. 0.12, which gives me 12%. Simple. 5/25. We got 5 over 25. I'm going to put this into 10. 25 can't go into 10, so let's put it into 100. Times 4 gives me 20, which would be 20 hundredths, which is 20%. All right, look at the next one. What is a common denominator for 3/8? This would be written as 3/8 and 7/12. Let's take a look here. They don't go into each other. But let's say if I do 12 times 2, I get 24. Can 8 go into 24? It can. My common denominator would be 24. Explain how you found a common denominator in problem 4. All I did is I wanted to find the smallest number both could go into. Excellent. Let's keep going. Is 22 over 45 greater than or less than half? Let's take a look here. How would I solve that? I would have to find a number that they could both go into, right? 22 over 45, and I have half. What number could 22 and 45 both go into? They each can go into 90, right? Because 45 times 2 is 90. Times 45 equals 45 over 90. I'm going times 2 equals 44. 44 is smaller, so is 22 or 45 greater than or less than? It is less than. Explain how you decide on your answer. Because 22 over 45 equals 44 over 90, kids. All I'm doing is copying this up here. And half equals 45 over 90, which means half is larger. A line is 3 1/4 inches long. If you erase 3/4 from this line segment, how long would it be? So I have 3 1/4. I'm subtracting 3/4. So when I'm subtracting, first thing, number on the left larger than one on the right. It is. Denominator is the same. They are. My numerator is smaller. 1 is smaller than 3. So I'm going to have to borrow 2. This becomes 5/4 minus 3/4. So my answer is 2 2/4. I can't leave it that way because 2/4 can get reduced. It's 2 1/2. Please keep in mind how I borrowed here. Because the 4 is the denominator, I was adding 4 over 4 plus 1/4. That's how I got 5/4. Let's keep cruising along here. Now we're adding fractions, okay? Common denominators. Let's take a look here. I'm going to have to probably erase my work as I'm going here. So 8 and 4, they both go into 8. So 3/8 can stay the same, but I have to change 5/4 into something with an 8. I'm going times 2. Times 2 gives me 10/8. So this problem right here is really 10/8. So I have 3 plus 10, which is 13 over 8. I can't leave it that way. How many 8s go into 13? 1. What's left over? 1 and 5/8 is my answer. Let's move on over here. The nice thing is I have a 4 here. I can add up 4 plus 0. 6 and 8, they both go into 24. 8 times 3. 7 times 3 is 21. 6 times 4. 5 times 4 is 20. 21 plus 20 gives me 41 over 24. How many 24s go into 41? 1. What's left over? That means I'm going to have to subtract 41 minus 24. To borrow 7, 1, I have a 17. 17 over 24. I have to add this to my original 4, so my answer, kids, is 5 and 17 over 14. 17 over 24, not 14. So moving along here. So we have 2 minus 1/3. If I'm going to take this 2, I'm going to write it as 1 and 3 over 3 minus 1/3. So it gives me a 1 and 2/3 as my answer. You see why there's no room for error on that? Let's look on over here. Number on the left, larger than the one on the right. Denominator is the same, and my numerator is larger, so I can just strictly subtract right across. 6 minus 4 is 2. 3 minus 1 is 2 fifths. It's easy. Let's keep moving along here. 3 and 9, they both go into 9. So 7 times 3 gives me 6. 7 minus 6 is 1/9. Boom. Common denominators, so to change 2/3 and 9. Okay. Move this down a little bit. Give us some extra space. Perfect. 2/3, 6/9. Into 9, into 9. This stays as a 6. This goes times 3 gives me 6. So I'm going to rewrite this problem as 2 and 6/9 plus 5 and 6/9. It is getting messy. I apologize, kids. Okay. So watch what I do here. 2 plus 5 is 7. 6 plus 6 is 12. We have a 9. 12/9, kids. We have to pay attention. I can't leave that my answer like that. 12/9 equals 1 and 3/9. I'm going to add 1 and 3/9 to 7, so my answer is 8 and 3/9. If I reduce that down, it's 8 and 1/3. Wow, that got messy. Let's try and write as neat as possible. Hopefully that helped you out. One problem left here. I'm going to make this larger so we can see it. All right, let's go here. Let's subtract. Number on the left is larger. Denominators are the same. This 2 is smaller than this 3. Large problem here. So we're going to cross off this 6. We're going to make it a 5. That means I have to add a 5 to the 2, which is a 7 over 5. I'm going to subtract it to 2 and 3/5. I get an answer of 3 and 4/5 for an answer. Boom. That's how it's done. Next problem. Let's go ahead and do this here. We have to find the missing number. So how did they get this number? So that looks like they borrowed from the 7 and got a 6, which means they added a 3 to this 2, which means I would have a 5 for that answer. Let's see what they did here. It looks like they added a 9 to this 4 to get a 13, which means they had to borrow from the 3, which means we have a 2 here. Let's take a look at this next problem. They borrowed from the 8 to make this a 7, which means they added a 7 to the 5, which would give me a 12 here. Right here. They added a 5 to the 4 to get a 9, which means they borrowed from the 6 to give me a 5. Let's look at this next problem here. Fill in the oval next to the possible common denominators for each fraction pair. So for number 1, we have a 3 and a 5. All right. 5 doesn't work. 3 can't go into 5. 3 can go into 15. 5 can go into 15. That's a good one. 3 can't go into 10. 3 can go into 30. 5 can go into 30. That's a good one. That's how you do this. 6 and 8. Can 6 go into 48? It can. Can 8 go into 48? It can. So we'll mark it. Can 6 go into 12? It can. Can 8 go into 12? It can't. Can 6 go into 6? Yes. Yes. Can 8 go into 6? No. Can 6 go into 24? Yes. Can 8 go into 24? Yes. We're going to mark it. Next problem. Can 4 go into 14? No. Can 4 go into 28? Yes. Can 7 go into 28? Yes. Can 4 go into 11? No. Can 4 go into 21? No. You see how I did that, kids? Just take one at a time. If it works, yes, then look at the other one. Does it work? Yes or no? Okay, if it doesn't work, cross it off. Now they want me to list these fractions from least to greatest. And I'm going to show you how to do that right here. All right, I'm going to do this process thinking out loud so you can hear me, okay? And then you can understand my thought process. All I did was copy and paste these. So I have to put these numbers in smallest to largest, okay? Looking at these numbers here, which one of these numbers is larger than 1? I know this number right here is larger than 1, so I know 11 over 7 is my largest. I'm going to go ahead and cross that one off. The next couple that are closest to the number 1 are 5, 6, and 7, 8. Those are my next largest. So I want to find out which one's bigger, 5, 6 or 7, 8. So I'm going to go ahead and find common denominators and hash them out. Times 8 gives me 40. Times 6 gives me 42. That means 7, 8 is larger. 5, 6 is my next largest. Let me go ahead and erase my work here. So I mean, these two are off the board. Now I'm left with 3 fractions left. I have 1/3, 2/5, and 2/4. Okay. I know 2/5 is less than half. I know 1/3 is less than half, and I know 2/4 is half. The reason why 2.5 would be half of 5, but that number is 2. 1.5. So that means my next largest is 2/4, which leaves me with 2 fractions left over. Let's stack these up and see which one is the largest. Put them both into 15 times 5 times 5 gives me 5/15. Times 3 gives me 6. 6 is larger, which means 2/5 is my next biggest, and 1/3 is my smallest. Right here, kids, hardest problem on your Unit 8 test. And it's simple. Break them down one at a time, and you can solve it. Okay? Next problem. Just want to make sure I didn't skip any problems here. I didn't. If you draw a line segment twice as long as 4 3/4, how long would the new line segment be? So let's watch closely. So we're going to go twice as long. So we can go 4 3/4 plus 4 3/4. I'm going to add these up. I'm going to get 8 6/4. 6/4 equals 1 2/4, right? And I'm going to add that to my 8. So I have 9 2/4. Which one of these things equals 9 2/4? It's not this one. It's not this one. It's not this one. 9 1/2. Half is the same as 2/4. Boom. Next problem. Mel's puppy was 6 5/8 inches tall when it was born. Now the puppy is full grown and is 11 3/8 inches tall. How much has the dog grown? How have you found your answer? So that's what we have to do. We have to subtract 11 3/8 minus 6 5/8. Of course, there's going to be borrowing on this test, kids. First thing, is 11 bigger than 6? Yes, so I have those numbers set up right. Common denominators? Yes, they're set up correctly. 3 is smaller than 5, so I have to borrow from this 11, which makes this a 10, which means I have to add an 8 to this 3, which is an 11 over 8, minus 6 5/8. As soon as you've done that, it is simple. Go ahead and subtract across. 10 minus 6 is 4. 11 minus 5 is 6. I have an 8. I do want to reduce this problem because I've already done all the work. 6/8. Divide these by 2. Gives me 3/4. My answer, I have to bring this whole number back into it, 4 3/4. So how much has a dog grown since it's been born? 4 3/4 of an inch. How many minutes are in 2/3 of an hour? We're dealing with minutes. Hour is the whole set, so I have 2/3 of 60 times 20 times 2/3 of an hour. How many minutes? So 2/3. So we're going to go in times 20 equals 40. How many minutes would be? It'd be 40. Let's keep going here. Trisha sewed 32 bags for a fundraiser. It was 75%. If 75% had flower designs, how many of the bags had flower designs? So we're doing 75% of 32. Ding, ding, ding. How do we do this? 75%, 0.75 times 32. We've been doing this multiple times. We're going to go 32 times 0.75. We're going to multiply across. We got 10, 15, 16. I'm going to erase that 1 up there so don't get confused. A place value holder. 7 times 2 is 14. 21, 22. Add these up. 0, 10, 4, 2. 2 decimal spots. 2 decimal spots. 24 would be 75%. All right, let's take a look down here. Let's multiply some fractions. This is the most fun of the whole unit, in my opinion. Cross reduce. 9 and 8 cannot get cross reduced, but the 5 and 10 can. Divide by 5, divide by 5, you get 2. 9 times 1 is 9. 2 times 8 is 16. Let's keep going over here. Can we cross reduce? No. Can we cross reduce? No. Can we cross reduce here? Yes, we can. Divide by 2. Divide by 2. 1 times 1 is 1. 2 times 3 is 6. 1, 6. Let's look at another one down here. We have some mixed numbers. Remember, the mixed numbers are a little more work. Let's take a look. First of all, improper fractions of what we need to do. 3 times 5 is 15 plus 1 is 16 over 3 times 5 times 2 is 10 plus 4 is 14 over 5. Can we cross reduce? We cannot. Can we cross reduce? We cannot. So we are dealing with a large number. 15 is my denominator. What are we dividing 15 into? 16 times 14. 24 gives me a 6. Place value holder. 6, 1. Let's add these up. 224. How many times can 15 go into 224 is what we're going to be working on here. Going 0. Bring down the 22. 15 goes into 22 once. Gives me a 7. How many times can 15 go into 74? I know 15 times 4 gives me 60. That's about as close as I'm going to be able to get. Subtract, give me a 14, remainder 14. So my answer, kids, is 14. Remainder 14 over 15. Boom. That's how you solve that problem. Let's do another one here. 6 times 6, 36. Plus 5 is 41 over 6. 3 times 7 is 21. Plus 2 is 23 over 3. Can't cross reduce, can't cross reduce. We're dealing with another large number. We're going to be dividing by 18 this time. To do 41 times 23 gives me a 3, 12. Place value holder, 2, 8. Let's add these up. 3, 4, 9. 943. Time to divide. 943 divided by 18. 18 goes into 9, 0 times. Subtract. I got a 9 here. Got a 4. Let's do 18 times 3. 54. We can get closer. Let's do 18 times 4. What do we get here? 32, 72. We can't get any closer, can we, kids? We can't. So we're going to put a 4 here. It gives me a 72. I'm going to subtract. I get a 2. Bring down the 3. How many 18s get into 223? Okay. 18 times, let's go 8. Let's see what we get. 6. 8 times 4. We couldn't get closer here, kids. So you're like, what, Mr. Green? I'm sorry. Thinking out loud, I saw that mistake right away there. So let's go 18 times 5. Gives me 90. So we have a 5 here and we have a 90 here. It gives me 4. I'm bringing the 3 down. How many 18s can go into 43? 2 can. But 18 times 2 gives me a 36. So my remainder would be remainder 7. So my answer is 52. Remainder 7 over 18. These two problems on your test will also be challenging because you can see, like I just did, I almost made a mistake there, right? Because I said it was a 4. But I noticed that when I had to multiply 18 by 9, I wouldn't even be close to 200. and 24 there. So hopefully this helped, kids. It's a nice review for you. Couple challenging problems on this review, but other than that, you're just multiplying fractions, you're adding and subtracting fractions, okay? Good luck, and I look forward to reviewing Unit 8 with you tomorrow in class.